In this video, we are going to focus on adding, subtracting rational expressions with common denominators, with opposite denominators, and also focus on how to find least common denominator when denominators are not same. Okay, so recall when we are adding or subtracting fractions, if denominators are already same, we can simply go ahead and add or subtract the numerators and write the common denominator as a denominator of new fraction. And at that point, we can reduce the fraction and write it in the lowest terms. Like in this case, we could divide both numerator and denominator with the 2, and our fraction in the lowest terms is 3/4. So when adding and subtracting fractions or expressions that denominators, when denominators are same, just add the numerators and keep the common denominator. Be a little cautious when subtracting. The negative sign impacts every single term that comes after it, and it turns it into opposite. Okay, so when we are dealing with subtraction, every single term that comes after negative sign turns into opposite. A common mistake when denominators are same, do not factor any of the expressions, okay? That would be a mistake if you start factoring expressions when the denominators are same. So don't factor anything until you have written it as a single fraction and you have written the common denominator as the denominator. So if denominators are same, do not factor any of the expressions until you have written as a single fraction. Let's check out some examples. 3p over 2q plus 11p over 2q. Well, denominators are same, so the common denominator will be 2q. 11p plus 3p is 14p. Now 14p divided by 2q, 14 can be divided with the 2, so it's 7p divided by q. And that's our final answer reduced in the reduced form. Example number 2, the common denominator is m minus 6. So I'm going to go ahead and combine the numerators. Now looks like in the numerator I do have a GCF, which is 4 m minus 6 over m minus 6. Let's cancel out the common factors between numerator and denominator, and 4 is what we are left with. Whenever we are adding or subtracting fractions, adding or subtracting rational expressions, we do need the common denominator. If you already have the common denominator, then go ahead and combine the numerators, okay? Add or subtract the numerators. Example number 3, again, do not factor. That would be not okay. That would be not correct to start factoring the numerator here or pulling out the x GCF from the numerator. So when you have the common denominator, start by writing the common denominator as the denominator of new fraction and combining the like terms in the numerator. 5x squared plus 4x minus 6x minus 3. Okay, keep in mind this negative sign is going to impact everything that comes after. It's going to get distributed into entire binomial, and it would turn both 6x and 3 into opposites. Okay, so let's combine the like terms. 5x squared 4x minus 6x is negative 2x minus 3 over x minus 1. Now, I'm going to try to factor the numerator, if I can, by using the AC method or X method. Two numbers that multiply to give me negative 15 add up to give me negative 2 are negative 5 and 3. Because my first number is 5, I'm going to have to divide both of them with the 5. Now, first fraction can be simplified, so using the bottoms up method, this factors into x minus 1, 5x plus 3 over x minus 1. X minus 1 is a common factor between numerator and denominator, and all we're left with is 5x plus 3. Okay, example number 4. Again, I do have the common denominator, and both the fractions have exact same denominator. So go ahead and write it as a single fraction with the common denominator as denominator of the new fraction, and combining the like terms or combining the numerators. Let us go ahead, and it looks like I can factor the numerator here, and I can also factor the denominator. Okay, good notes. I can also factor the denominator, which would be y squared plus 3y minus 10. Two numbers that multiply to give you negative 10 and add up to give you positive 3 are y plus 5 and y minus 2. There is a common factor between numerator and denominator. 3 over y plus 5 is what we're left with. All right, example number 5. 2x plus 3 over x squared minus x minus 30 minus x minus 2. So right away when I see this, I have this in my head that I'm going to have to distribute this negative sign into the entire binomial. And I already see the common denominator. That's a good news. That means I'm going to write it as a single fraction with 2x plus 3 minus x plus 2 in the numerator. Why? Because this negative sign or negative 1 is going to distribute into the entire binomial. 2x minus x is x. 3 plus 2 is 5. And we can factor the denominator. Two numbers that multiply to give you negative 30 and add up to give you negative 1 are going to be negative 6 and 5. So x plus 5 and x minus 6. X plus 5 and x plus 5 is there in the numerator and denominator, so they cancel each other. I'm only left with x minus 6 in the denominator. So don't forget, we need the 1 placeholder. We need 1 as a placeholder in the numerator, okay? Use 1 as a placeholder in the numerator. All right, example number 6. 2x squared over x minus 5 minus 25 plus x squared over x minus 5. Well, both have the same denominator, but one thing that I need to be cautious about, that this negative sign is going to turn everything into opposite when I distribute the negative sign. So 2x squared minus 25 minus x squared. 2x squared minus x squared is x squared minus 25 over x minus 5. So let us go ahead and factor x plus 5, x minus 5 over x minus 5. Cancel these out, and we're just left with x plus 5 as our final answer and product in this case. No need to put 1 underneath because something divided with 1 is still the same thing, so no need to do that. Now let's talk about least common denominator when denominators are opposite. Okay, what do we do when denominators are opposite? Well, if you recall, x minus 7 and 7 minus x are opposite of each other. Or if you remember, if you start with the basic fractions, 2/3 plus 5 over negative 3. What do is we can pull out the negative and write it in the middle of two fractions, because here we are doing a positive number times a negative number, which is going to be a negative 5/3. Okay, and then proceed with the subtraction problem. Same thing with x minus 7 and 7 minus x. They're opposite of each other. We're going to pull a negative out from 7 minus x, because 7 minus x can be written as negative in parentheses x minus 7. So that's what we're doing, and it turns into a subtraction problem. And then we go ahead and proceed with the common denominator x minus 7 in the denominator, and 2 subtract 8, which is negative 6 in the numerator, and that's our end product. Another example, when we have x plus 3 over x squared minus 1 minus 2x over 1 minus x squared. Now 1 minus x squared can be written as negative x squared minus 1. So when we pull this negative out, the two negatives here will become a positive, and it turns out to be an addition problem. And at this step, we can factor the numerator and factor the denominator and cancel out the common factors between numerator and denominator. All we are left with 3 over x minus 1. Here's next example, 8 divided by x minus 2. And we can write 2 minus x as x minus 2 as well. If we pull out a negative from here, factor out a negative from here. And now it becomes a subtraction problem, and 8 minus 8 is 0 divided by x minus 2. 0 divided by any number is just 0, okay? 0 divided by any number is just 0. In the next video, we will talk about when denominators are completely different. So in this video, we only discussed the rational expressions when denominators are either same or they are opposite of each other.